Bismillahirrahmanirrahim. Assalamu alaikum. Dear students, welcome you all in Pakistan International School Taif Virtual Learning System. Today is our 32nd video lecture for grade 2nd year students, boys and girls. I'm Mrs. Rosia Imran, your mathematics teacher. Chapter number 3, today we will start chapter number 3. Chapter number 3 is integration. Integration is, you can say that it is the inverse process of derivation. When you find the antiderivative, that is called integration. Means that when you have a differential function, a derivative function, and you can find its original value or original function from this process. Here we have exercise 3.1. In exercise 3.1, if you check the statement of the question, find delta y and dy in the following cases. You have given three different cases and you have to find dy and delta y. You know that delta y is a very small value. We already done it in chapter number 2. Here you have given function is y is equal to x square minus 1 when x changes from 3 to 3.02. This 02 is delta x. If x value is 3, so delta x is what? This change, 0.02. How can you solve it? You have given y is equal to x square minus 1. Value of x when x changes from 3 to 3.02. So value of x is 3 and delta x is 3.02, the maximum value minus initial value. So 3.02 minus 3, so we have 0.02. You know that if you look at this function, if in the given function, in the given equation, you add delta y in the left hand side and delta x on the right hand side, so what you get? Y plus delta y and x plus delta x whole square. In place of x you put its value minus 1. Now y is positive here, shifted at other side, so it will be negative. So minus y, value of y you put it here, so here it will be minus x square plus 1. Now minus 1 plus 1 cancel and you get x plus delta x whole square minus x square. Value of x is 3 and value of delta x is 0.02. So you put this value in this equation. 3 plus 0.02 square and minus 3 square. So when you solve, you get delta y is equal to this. Now taking differential of equation number 1, this. So that will be dy and dx square minus 1. So dy as it is and x square derivative, you know that that is 2x dx. Now you put value in this, x is equal to 3 and dx is equal to delta x, which is 0.02. So you put in this, dy is 2 into 3 into 0.02. So you get 0.12. If you compare delta y and dy, both are approximately same. So in this way you have to solve the second part. Now come to the third part. In third part you have given y is equal to under root x when x changes from 4 to 4.41. So delta x, how can you find it? From the maximum value, this is already given in the question, 4.41 minus 4, so you get 0.41. In the given equation, you put delta y in left hand side and in right hand side delta x. So y plus delta y and x plus delta x power 1 over 2. Y is positive here, shifted at other side negative, and you put the value of y, so minus x power 1 over 2. Now value of x is 4 and delta x is 0.41. So you put this value in this equation. Delta y is 4 plus 0.41, 1 over 2 minus 4, 1 over 2. So you get 2.1 minus 2. So delta y is 0.1. Now this equation 1, you differentiate with respect to, you're taking the differential of equation number 1. So when you take differential, so that will be dy and power will come in the coefficient 1 over 2x, 1 over 2 minus 1, so power minus 1 over 2 dx. Now you put the value of x and dx. So delta x and dx is same. So you put value of x is 4 and dx is 0.41. Now if something 4 power 1 over 2 is 2. So 2 2s are 4. So 0.41 divided by 4 is dy you will get. So in this way you have to solve. Question number 2 is using differential find dy by dx and dx by dy in the following equation. So you have to use the differential and you have to solve these four parts. So first part is xy plus x equal to 4. Taking differential on both sides, so d into xy plus dx equal to d differential of 4. So in the same way, just like derivative, in the derivative you have done just like in derivative, that you use the product rule. The first term as it is, differential of the second term plus second term as it is, differential of the first term, and differential of x. Just like you find the derivative in the same way, the constant derivative is 0. And here if you check x dy as it is, so dx is common in both, so you take dx common, so you get y plus 1 which is equal to 0. Here y plus 1 into dx is negative, positive, shifted at other side negative. Now dx is divided here, multiply here, shifted at other side, divide x, multiply with dy, shifted at other side, divide. So you get dy by dx is this, and dx by dy is the reciprocal of this value. So in this way you have to solve. Just like previous chapter, you just like you take the derivative, in the same way you take the differential. The rule is same. Second part you will do it by yourself. Now come to the third part. In third part, when you taking differential on both sides, so dx power, differential of x power 4, differential of y square, differential of xy square. So x power 4, you know that in derivative the power will come in coefficient, and from power you subtract 1. So 4 minus 1 x cube dx. This dx you will write it with that. Then for y square, the power will come in coefficient, and from power you subtract 1, so 2y dy. And here this is given in form of product, so use the product rule. The first term as it is, derivative of the second term, so power will come in coefficient, so from power you subtract 1, 2y dy, plus second term as it is, derivative of the first term dx. Now here in this, you have to shift the dy value at one side and dx value at other side. Here 4x cube dx is positive, shifted at other side it will be negative. Here 2x y dy is positive, shifted at this side it will be negative. So here 2y into dy is common, you take 2y and dy common, you get 2y 1 minus x dy. And here dx is common, you take dx common, dx multiply here, shifted at other side, divide this value, multiply with dy, shifted at this side, divide. And you write its reciprocal of this equation, so you get the required result, which is given in the question to find it dy by dx and dx by dy. Come to the fourth part. In fourth part, you have given if you check, you have given xy minus natural log of x equal to c. C is considered as constant. So taking differential on both sides, this is given in form of product. So you use the product rule. The first term as it is, differential of the second term dy, second term as it is, y as it is, differential of the first term dx. And natural log of x derivative, you already know that it is 1 over x dx, and derivative of constant is 0, so differential is also 0. Now dx value you shifted at one side and dy value you shifted at other side. So dy already here, so this value shifted at the right hand side, it will be minus y dx, and this is positive 1 over x dx. Dx take common, so when you take common dx, this value multiply with dx, and here dx multiply with this value, so shifted at other side dx divide, here x multiply, here shifted at other side divide, so you get this value. Now to find dx by dy, you write its reciprocal. So this is question number 2. Now come to question number 3. Question number 3 is using differential to approximate the value of these numbers. The first one is under root 17, fourth root of 17. So you will check the nearest value with 17, which is fourth root of any number. So that is 16. You know that 16 is the fourth root of 2. So what will we do? We suppose that y is equal to f of x and fourth root of x. Let's suppose x is 16 and delta x or dx is 1, because 16 plus 1 17. Now taking differential of above equation, first we suppose let y is equal to f of x, which is fourth root of x. So x is 16 and delta x or dx is 1. Now taking differential of above, so what we get, dy, and here power is 1 over 4, so it will come in the coefficient 1 over 4, and from power we subtract 1 over 4 minus 1 dx, so that is minus 3 over 4. To make it positive, shifted in the denominator, so x is 16 and dx is 1, you put value, x is 16 and dx is 1, so when you put its value, you get 2 power 4, 3 over 4, and here dx value is 1, so 4 cancel, so 2 power 3, that is 8, 4 8 is 32, so 1 divided by 32, you get this value. Now f of x plus dx, which is approximately equal to y plus dy. So f of x plus dy is equal to y is equal to f of x, so 4 under root 16 plus 0.03125, that is the value of dy, which is equal to 2 power 4, 1 over 4 plus 0.03125. So you get this value, which is approximately equal to the same. Again, I'm going to repeat it. I hope you will understand. What will be done? Look, this is the fourth root 17, so you choose that number which is near to 17 if something is added or subtracted, which is the fourth root of any number. So you know that 16 is the fourth root of 2. So what we done, we suppose that this 17, in place of 17 we write x is equal to 16 and dx or delta x is 1. Now we take the differential of the above equation, this one equation, y is equal to under root fourth root of x. So when we take the differential, we will get this value. In this value, we put x is equal to 16 and dx is equal to 1. So when we put this value, we will get this. Now, what will you do? You will take the original function. In original function, what we done, x plus dx is 1, x is 16 and dx is 1, so that make it 17. So which is approximately equal to y plus dy. So y is equal to what? F of x function, and dy as it is. So the f of x function is fourth root of 16 plus dy. So you put its value here, x plus dx, x is 16, dx is 1, so 16 plus 1, fourth root of 17, which is approximately equal to fourth root of 16 plus value of d. You solve this value, so you will get the answer, which is approximately equal to this. Now come to the next part. Second part. In second part, what you have given? In second part, you have given that 31 fifth root. You know that 31 is close to a number which is fifth root of some number, that is 32. You know that 32 fifth root is 2. So what will be done? We write x power 1 over 5, and x is 32, so dx or delta x will be minus 1 because the original function is 31. So 32 minus 1, that is 31. So in the same way, just like question number 1, you have to solve this. Now come to the third function. Third question is cos 29. You know that the basic trigonometric functions, the nearest function to 29 is 30, and cos 30 value we already know that. So from 30, if x is 30, so the delta x or dx will be minus 1 because 30 minus 1 you get 29. The question is cos 29. So let y is equal to f of x cos x, and x is 30 degree and delta x is minus 1. Minus 1 degree we convert it in radian, minus pi by 180. You know that to convert degree into radian we multiply with pi over 180. So the 1 degree is minus 0.01745 radian. So now differential of this value, that will be dy, and cos differential is minus sine x dx. So in place of x we put 30, and in place of dx or delta x we put this value, the minus 1 radian, minus 1 degree value we put. So dy is minus sine 30 degree, and this value sine 30 degree is 0 0.5. We multiply these two values, so we'll get this answer. Now come to the original function. Original function is what? X plus delta x, which is approximately equal to y plus dy. So y is what? F of x, that is cos 30, and delta x is minus 1, and dy value we already find it. The dy value is this. We already find it. We put this value here. So cos 30 we find it from calculator, and add this. So both answers we will get dy and cos 29, both we will get. Fourth part is 61 degree. Sine 61 degree. So 61 is near to 60, so x is 60 and delta x is 1 degree, and 1 degree you know that that is equal to that much radian. So differentiate, take the differential of the function, that will be dy, and differential of sine x is cos x dx. You put value, x is 60 degree and dx or delta x is this 1 degree. So you put value cos 60 is 0 0.5, and delta x is 0 0.01745. When you multiply, you will get this. Now take the original function. Original function is what? F x plus delta x, which is approximately equal to y plus dy. You write it this for all parts. So x is 60 degree, delta x is 1, and here y is f of x and dy as it is. So f of x is, we already suppose that is equal to sine 60 degree, and dy we already find it this value. So we add this value. So when you solve, so sine 61 degree, we will find it like this. Now come to question number 4. Question number 4 is find the approximate increase in the volume of a cube if the length of its each edge changes from 5 to 5.02. Let x be the length of the side of cube, where x is equal to 5 and delta x is what? 5.02 minus 5, so 0.02, this difference. Just like in first question, you have given x is 5 and the delta x will be 0.02. Assume that v denotes the volume of cube. So volume of cube, you know that if it is cube, so all its sides will be equal, length multiply breadth multiply height, all the three sides will be equal, so it will be x cube. Now taking differential, so when you taking differential, it will be dv, power will come in coefficient, from power we subtract 1, so 3x square dx. X is 5 and dx or delta x is 0.02. So dv is x is 5, so we put value of x 5 and dx 0.02. So 5 square is 25, 25 into 3 we multiply and then multiply with 0.02, so we get 1.5. So hence increase in volume is 1.5 cubic unit. Again, I'm going to explain. Find the approximate increase in the volume of a cube if the length of its each edges changes from 5 to 5.02. Means that the length of the side is 5 and the change is 0.02. So assume first we take its volume. Volume is what? V is equal to length multiply breadth multiply height, so V is equal to x cube. Now taking differential on both sides, so dv is equal to 3x square dx. Here value of x is 5 and value of dx we already find it, that is equal to delta x, which is 0.02. So you put in the given equation and you will get the required answer. For last part, question number 5, you will try it by yourself. How you will try it? Find the approximate increase in the area of a circular disc if its diameter is 44 to 44.4. So first you subtract 44.4 minus 44, so you will get 0.4. That is the difference, the value of delta x, and the diameter is equal to 44. So you have to solve just like question number 4. If any confusion, so ask in Zoom meeting class. So I hope you will understand it. And before starting question chapter exercise number 3.2, first on page number 125, you have given journal form and simple form of integration. So kindly memorize that. How can you find if the value having some power? For example, if you have given x power n, so its integration will be in power you add 1 and the same power you divide. In differential, what we done, we multiply the power in the coefficient and from power we subtract 1. But in integration is the inverse process of derivation. So in the power you add 1 and the same power you divide. So means that if you have x square and you want to find its integration, so it will be x power 2 plus 1, means that power will be 3 and the same 2 plus 1 will divide by x. So means that x cube divided by 3 will be its integration. So these formulas are given, and similarly you know that the derivative of sine is positive cos, but the integration of sine is minus cos. It is anti differential. So its formulas, all forms are given on page number 125. So try to memorize these all forms: the integration of sine, integration of cos, secant square, cosecant square, secant and tangent exponential function, and e power x and 1 over x, all these tangent x, cotangent x, all these forms are given, formulas are given on page number 125 of your textbook. So when you memorize this, then it will be easy to understand the next exercise. You can easily solve the next exercise. There will be no difficulty. So any confusion, any question, ask in Zoom meeting class. Take care. Allah Hafiz.